Okay, so we've got a collider BP, which is a pawn, and we've got the ability to move it around using our WASD keys and upright, left, and down. And we turned our critter into this sort of static but animated creature that we can move around. So it's quite simple, but we're increasing our functionality little by little. And thanks to our custom movement component that we created for this pawn, we can slide along objects and things like that, and we have the capability to move. Now, what we don't have yet is the ability to look around in the world. Our camera view is sort of fixed at this angle, just looking down at the pawn, but what we'd like to do is be able to look around and rotate our camera around the pawn. So to do that, we're going to add a couple of new input axes, and these are going to be for the mouse. So we'll go to Edit and Project Settings, and we're going to scroll down to Input here, and under Axis Mappings, let's go ahead and close up those two, and we'll go ahead and click the plus sign a couple times. And on the first one, we're going to call this one camera pitch. And the second one we're going to call camera yaw. And pitch and yaw are rotation about certain axes. So again, the pitch would be, if you're nodding your head yes, up and down, you're changing the pitch of your head. And if you're about to cross the street and you're looking both ways, that would be rotating your head's yaw. So that's one way to think about it. So camera pitch, we're going to map this to the mouse, and we're going to make since it's pitch going up and down, we're going to map it to the mouse y-axis. And for the camera yaw, we're going to map this one to the mouse x. And so that's how you map these to the mouse. So whenever the mouse is moving left and right, we're going to get a value for camera yaw. And when the mouse is moving up and down, we'll get a value for camera pitch. And of course, moving the mouse all around will change both of these simultaneously. So we've got our inputs. Let's go into Visual Studio. And in collider.cpp, we're going to bind the axes for this. And we can go ahead and just sort of copy these and paste them here. And instead of move forward, we're going to say camera pitch. And instead of move right, we'll say camera yaw. Now, let's go ahead and create a couple of functions for these. And for camera pitch, we're going to create a function called pitch camera. So let's go ahead and just under move forward and move right. So we're going to say void pitch camera. And for our input axis, we can call this anything we want. We can call this axis value. And we'll create another function called yaw camera. And we'll also use float axis value for the parameter name. So we can go ahead and copy these, and we're going to define these. So we'll go into collider.cpp, and we'll scroll down just under, let's find move forward and move right. So just under move right. We'll paste these, and we'll need to fully qualify their names. So we'll do that. And we'll give them bodies. So we'll do that. And now we're ready to give them some functionality. Now let's go back up to the bind axis under camera pitch and change this function to pitch camera. And for camera yaw, we'll change this to yaw camera. So now these functions are bound to these axes for the axis inputs for those. Okay, so let's give these two functions some functionality. What I'd like to do first is create a new variable here, and I'm going to call this, it's going to be an f vector 2D, and it's going to be called camera input. This is going to be used to store some information about the x and y axis values. So I'm going to go to collider.cpp and go up to the constructor, and I'm going to create a initial value for it. Camera input equals f vector 2d, and I'm going to give it 0.f for both axis values. So we've got this camera input vector. It's 2D, it's got an x and a y parameter, and I'm going to use pitch camera and yaw camera to update those values. So I'm going to say camera input dot y for the pitch is equal to axis value. So whatever the mouse returns for this input, it's going to be set for this variable camera input dot y, and I'm going to use camera input dot x to get the axis value from the yaw camera. So basically, when the mouse is moving, its x and y axis values will update camera inputs x and y values respectively. So I guess it would make more sense to put yaw up here above pitch, just because, you know, x comes before y typically, at least in my mind. Okay, so we've got this camera input x and camera input y. Now what we can do is update our rotation in the tick function. So I'm going to create an f vector, actually an f rotator rather, and call this new rotation. And I'm going to start it off with get actor rotation. So it's the current rotation in this frame stored in new rotation. And what I'd like to do is update its yaw. So I'm going to say new rotation dot yaw plus equals camera input dot x. So the camera input's x value updated by the mouse's x-axis value is going to be added to camera rotation, or rather new rotation dot yaw. Okay, so what that's going to do is allow us to change the yaw if we call set actor rotation. We can set actor rotation to new rotation, and what that's going to do is rotate the actual actor itself. So let's go ahead and build this with Control-Shift-B and go ahead and let this compile. And what it's going to do, let's go back into Unreal Engine. What it's going to do is it should allow us to move the mouse left and right and actually change the yaw of our actor. Okay, there's the hot reload. Let's go ahead and hit play and move our mouse left and right, and you'll see that we can actually rotate around. Now, what about the pitch? Well, the pitch we're going to change as well. And what we want to change for the pitch is not the actor itself, but the camera spring arm. The camera spring arm can be rotated as well if we get our camera spring arm component. So I'm going to make those a little more compact, and I'm going to make another F rotator and call this spring arm rotation. Let's call it new spring arm rotation, and I'm going to set this equal to spring arm get component rotation. There it is. So this is now set to this frame, the spring arm's current rotation. And so what I'm going to do is take new spring arm rotation, and I'm going to take its pitch and plus equal camera input dot y. And now I can take new and I can take actually the spring arm itself and set world rotation to new spring arm rotation. Okay, so we're doing the same thing, only instead of the actor itself, we're moving the spring arm. So let's go ahead and build this. Okay, we've built it, and we can go back and hit play, and now we've got rotation just as we would expect. Now I would like to take note of one thing, and if we keep rotating down, the camera will go down and the spring arm will shorten as the camera collides with the ground, but we can actually rotate all the way down here and look up at the pawn from the ground, and that's not exactly something that I want to be able to do, because really it's not exactly it's something you would like to restrict in a game, because once you go down and look up and you rotate around and you come back, you're sort of out of whack. So I'm going to hit escape, and I'm going to go back, and rather than setting new spring arm rotation dot pitch equal to this, what I'd like to do is set it equal to, and I'm going to use fmath and clamp. So we're going to clamp, and what am I going to clamp? I'm going to take, first of all, clamp will return, the first thing is the value that you give it, and this is going to be new, let's see, new spring arm rotation dot pitch plus equals camera input dot y. So this will actually add camera input dot y to the pitch and then return it to the first, basically the first parameter in the list, and then the next values will be the clamp values. So I'd like to clamp this to -80.f and -15.f, and what this will do is it will ensure that new spring arm rotation dot pitch will never get below -80.f, and it will never get higher than -15.f. So its pitch will always be angled down at the pawn, but we can never actually move that spring arm outside of this clamped value. So let's go ahead and build this, and let's see just how that feels. So we'll go back to Unreal, we'll hit play, and now you'll see that we can move our mouse up and down, but we're clamped. We can't go down below or above a certain value. So now we can move around, we can maneuver our way around this world, and we can move the mouse to take a look at other things we couldn't see before. So we couldn't see in this corner before, and you know, it's feeling a little bit more like we have more control. Okay, so that is how to create rotational functionality for a pawn. We can rotate the camera. Basically what the camera spring arm does is it's attached to the root, and so by rotating the root, which is what gets rotated with set actor rotation, the camera spring arm rotates along with it because it's a child. And then rather than rotating the pawn itself for the pitch, we're rotating the spring arm itself. And so that way in the future, when we have a character like a humanoid or even a creature, some sort of critter, moving the pitch will not actually rotate the character itself in the pitch rotational direction, but it will just rotate the spring arm. So we're making lots of progress, and stay tuned and we'll move on to some more advanced stuff.